We're going to do 2.2 scientific notation with positive powers. Scientific notation is just a math or scientific method that we use to express either very large numbers or small numbers. This comes really handy when we're, for instance, are looking at a microscopic organism and it's super tiny, right? So we're going to use the negative power. So that's going to be 2.3, but we're going to use a negative power to express that instead of writing 0.0000, you know? And also when we are describing like really large numbers, this is, from here to the sun or things like that, we're able to use this instead of writing a lot of digits. Okay, so really comes in handy. Okay, so scientific notation again is a method that we use in math and science to express very large or small numbers. Okay, and we express them as a product. So I'm gonna use C for the factor. Okay, as a product. So we're multiplying a product of a number that is greater than 1, the greater or equal to 1 but less than 10. Okay, so this is what it is. So C, the number that goes right here, has to be greater or equal to 1, but it has to be less than 10. That's why 10 is greater than C, right? So basically it has to be a number between 1 and 9.999 repetitive. It cannot be 10 because otherwise if it was 10 then you will have to add another power there and it will kind of like defeat the purpose of using scientific notation. So again, this number must be between 1 and 9.9. It cannot be 10 and it cannot be less than 1. Okay, so it has to be 1 or greater than 1 but less than 10. Okay, so for us to write in scientific notation, we're going to take, for example, this number right here. When we have positive powers, when we have a positive exponent, the number that you're going to end up with, so the number that they're expressing in scientific notation, is always going to be greater than 1. And I call that large numbers, right? Big numbers. So we have 84,000. Okay, now what we're going to do is we're going to take this number and we're going to locate our decimal point. Remember, all whole numbers have a decimal point. We do not see it, but it's at the very end right there, right? So then what I'm going to do is I'm going to look at my decimal and I'm going to try to go to the left until I get to a number between 1 and 9.9. So if I go right here, no, that's 8,400, so that's too big. What about right here? That's 840, that's too big. Right here, that will be 84. It's still too big because it cannot be more than 9.9. What about right here? Perfect, right? So if I stop right there, I end up with 8.4, right? So perfect. That number meets that criteria of being between 1 and 9.9 repetitive. So I'm going to write my 8.4 right here. And I'm going to multiply by a power. Now, the power right here is how many times I move my decimal place to the left. So I have 1, 2, 3, 4. So then right here, I'm going to have to the 4th power. Okay. Now, if I were to take this back to its original form, okay, I'm going to go like so. 8.4, and then I'm multiplying times 10 to the 4. That means that I'm multiplying by this number, correct? And remember, we know that there's a pattern when we multiply by base of 10. We move our decimal place to the right that many places. So I'm going to move it 4 places, right? So I'm going to say 1, 2, 3, 4. So the new place location for my decimal point is right there. Now what I do right here is I use my zeros to fill in those spaces. Okay, so let's take a look at this one right here. So I'm gonna rewrite that. So then I have 3.59. Okay, and I'm gonna move my decimal place 5 times to the right because I'm multiplying by 100,000. That means the number is going to be larger, right? So I'm going to move it 5 times to the right. So I'm going to say 1, 2, 3, 4, 5. This is a new location for my decimal point, and I'm going to use zeros as placeholders. So I end up with 359,000. If I were to take this back again, remember I'm going to locate my decimal place, and I'm going to go to the left until I find a number between 1 and 9.9, which is right there. And I'm going to rewrite 3.59 times 10 to how many places did I move it? 1, 2, 3, 4, 5 to the 5th power, and I go back to what was given to me. Okay, so make sure that you know how to do this, that you're watching the video, and let me give you a problem that you're going to show me for your homework. Okay, actually you'll get 2. Make sure you show me this whiteboard with the answers and your work at the beginning of class when we have this lesson. So here we go. So let's change 59,843 into scientific notation. So you're going to write a factor right? Times 10 times some kind of power right here. Okay, remember this number has to be between 1 and 9.9. And then number 2, you are going to change 2.03 times 10 to the 4th. Okay, so give me the actual value for that scientific notation number. Okay. So remember, math is magical and you are awesome. And I know you can do this because you give a lot of effort and you don't give up. God bless you.